Hi, let's talk about the recently concluded Nvidia GTC, which is the GPU Technology Conference. The main focus for this year's conference was sustainability, generative AI, and industrial digitalization. Essentially, sustainability means how can we do the same or more work while consuming less energy, because the world needs to go green. And generative AI because, ChatGPT and any other ML model that generates text. And then industrial digitalization, which ties back to sustainability in that industries and manufacturers are able to simulate workloads and as a result consume less power because they don't have to wait to actually build out whatever it is that they need to do, which would waste resources. So let's talk about the sustainability part of the conference and NVIDIA's ethos. Essentially, what they're doing is they're asking essentially everyone to move their workloads to GPUs. And the logic behind it is that certain complex workloads take a really long time to compute on a CPU. I'll even take a step back. NVIDIA was initially famous for providing GPUs to computers. A GPU is a graphics processing unit, and back in the day, computing graphics on CPUs was really difficult. The physics and the collision, computations used to take a really long period of time. And so those workloads got offloaded onto GPUs. And if you're a gamer, you have a pretty clear idea of what GPUs are used for. There are computers with GPUs and without GPUs, and you can tell how differently these computers will render your graphics or your games and things like that. Back to sustainability, there are workloads that will take a really long period of time to compute on a CPU that would take a much shorter amount of time to compute on a GPU. If you think about power consumption, even if the CPU and the GPU consume the same amount of power, the GPU does the work in a shorter amount of time, then that's less energy consumed. Nvidia is even talking about their GPUs, which they now call accelerators, consuming much less power. And as a result, if you were to move workloads to those accelerators, you would get the work done in a shorter amount of time and consume less energy. So they're calling on data centers to move workloads to accelerators. That's the sustainability side of it. Nvidia introduced the Omniverse platform a few years ago, and they've announced new updates to Omniverse. Now, Omniverse itself is a platform for creating metaverse applications. What that lets you do is simulate a bunch of stuff. One of the most popular applications of Omniverse is in building digital twins. And digital twins are essentially a simulated reproduction or a computer reproduction of something that is in the physical world. It could be a building, it could be an automobile, it could be a piece of machinery. And NVIDIA Omniverse finds applications in all of these domains. So digital twins, simulated factories, robotics. Omniverse is applicable to various users. So designers, they have a role in Omniverse because they can create 3D artifacts. These 3D artifacts can then find their way into other components like factories or machinery that get built. Omniverse itself is regulated by the laws of physics. They've implemented a physics engine inside of it, so things like gravity, collision, all of those things work quite well. So it's not like some computer games where an object can pass through a wall, for example. So creators have a role in Omniverse. Developers also have a role in Omniverse. They can create tools. And then finally, enterprises have a role because they can then simulate their workloads. And these could be factories that they're building, new machines that they're building, robots that they're building or training. And you're able to actually take an entire gym. So there's, Isaac Sim and Isaac Gym and things like that for robotics, where you can carry out reinforcement learning within NVIDIA Omniverse. Now, NVIDIA Omniverse is available both on physical computers and as a cloud. So the Nvidia Omniverse cloud exists on Azure. It will be integrated, or is currently integrated, with the Microsoft Productivity Suite. So think Teams, think SharePoint Portal Server, things like that. It's also integrated with the Azure IoT platform. So there's just a whole lot of capability that is built into the Nvidia Omniverse cloud. As part of the conference, Nvidia has also announced updates to quite a number of libraries. They've announced an update to cuQuantum, which is their library for quantum simulations. So we currently do not have real quantum computers. They're still a few years away. But a lot of work is going into simulating workloads, and cuQuantum is one of those libraries that developers are turning to in order to carry out these simulations. They've also announced Spark Rapids, and that is a library for accelerating data processing workloads. This cuOpt, which is for accelerating optimization tasks and workflows, and essentially optimization tasks are they have to do with route optimizations, logistics, problems that have to do with your traveling salesman, post office deliveries, everything that has to do with how do I deliver multiple items to multiple people in the least amount of time, or covering the least amount of ground in the fastest way possible. cuOpt, the library for optimizations, for accelerated optimizations, is available on Nvidia Launchpad, and I think that this is a good time to talk about Nvidia Launchpad if you haven't heard about it. It's basically their online platform you can access from a browser that lets you take labs. These labs are free, they're hands-on, you get access to them for up to 2 weeks, and you get access to Nvidia's servers and accelerated hardware. And to get access to Launchpad, all you have to do is go to their site, find the lab that you want to take, and then apply for access to that lab. You will get an email after a period of time, follow the instructions in there, and you have access to the lab for up to 2 weeks. So if you're interested, cuOpt is not the only thing up there. There are lots and lots of labs, so go check it out. Nvidia has also announced updates to their inference platform, and there are a few things there. There's TensorRT, and TensorRT is the SDK for optimizing ML models and also running inference on them. There's Triton, which is the actual inference engine from Nvidia. And then they've also announced TMS, which is an orchestration service. And if you don't know what orchestration is, it's basically a piece of software that controls the availability of another piece of software, essentially scaling up and scaling down based on demand and things like that. That's what orchestration is. For the data center, they've announced new chips, new inference designs, and new supercomputers. So I won't bore you with the details there. You can go check it out. One of the servers that has made NVIDIA popular is the NVIDIA DGX. So NVIDIA has various server classes. There are servers for high performance computing, servers for enterprise workloads, and then the DGX, which is the server for AI workloads or ML workloads, depending on which term you prefer. DGX is popular, but it's also super expensive. You're talking $200,000 to $400,000 for one unit. And so NVIDIA has announced the NVIDIA DGX Cloud. And essentially, it's AI training as a service. That's what the DGX Cloud is. It's coming first to the Oracle Cloud, but it's also going to be available from Azure and also on GCP. Now, the promise for the DGX Cloud to customers is that the DGX Cloud is going to have predictable pricing, and that's really what cloud computing is about. So if you think about it, the benefit of cloud computing is that as opposed to going out to buy one piece of hardware, which you might use sparingly, or which you might overload and then need to get additional pieces of hardware to extend, essentially horizontal scaling and things like that. With cloud computing, you use what you need, you shut it down when you don't need it, you don't get charged when you're not using it. And so they're bringing the same promise for DGX Cloud to potential customers. There's also Nvidia AI Foundations, and it's basically a service that will let you build, operate generative AI workloads. So think of it from the perspective of transfer learning. So you're not going to be building from scratch. They've got some pre-trained models that you can leverage, and then you can train your own domain-specific ML, generative models. And those models, they could be language models, they could be biology models, or what you would call health models, and they could also be visual models. So they've got pre-trained models that you can take, and then you can apply transfer learning on those. All of that is available on the cloud. So the service is meant for companies that do not have the expertise to do their own model training from the ground up, or do not have sufficient data to cause a model to converge in that particular domain. But with transfer learning, you can then bring less data and then fine-tune the model, and that's what you have with the AI Foundations. They've also announced the Nvidia Inference Platform, and it's really 4 different classes of hardware dedicated or specialized for different classes of workload. So the first one is the Nvidia L4, and this is available on GCP, and it's meant for AI video workloads. So things like background removal, processing of videos, possibly of images and photos as well. The second one is the L4T, and it's meant for Omniverse workloads. So we've already discussed Omniverse, and you can imagine how much processing power is required for that. So there's a dedicated piece of hardware for that. There's also the H100 NVL. There's also the H100 NVL, and this is meant for inferencing for large language models and other generative AI type workloads. Finally, they've announced Grace Hopper, which is meant for database workloads for AI type tasks, as well as for recommendation engines. So when they say database workloads, they're talking about vector databases in this case, and vector databases are databases that are designed for hosting unstructured data. So think videos, text that is unstructured, not in tabular format, audio, those sorts of things. And while vector databases are a completely different topic, they exist because they are meant to host, let's say, embedding vectors, as opposed to standard blobs with annotations. I've come to the end of my summary for Nvidia GTC. Thank you for tuning in, and see you at the next podcast.